Let's start with our worksheet chapter-wise. So this is really helpful for your exams because we are actually compiling all the question papers from like 2013 to the recent ones to prepare you guys to how to solve questions that would come of from specific chapters. And again, as we are obviously solving all the A2 physics, A's physics. So basically, under these videos, we're going to solve Unit 1, 2, 3, 4, 5, and 6. So watch this chapter-wise video worksheets for your better preparations for question papers. And after this, I would suggest watch our long marathon chapter-wise solutions that are like 4 to 5 hours long. And then again, after that, maybe you can start with our year-wise question papers. That is again added in our YouTube channel. Another thing, if you are interested to get the solved files or unsolved files, you can obviously get the files only in our Discord, that is at Excel Easy, and obviously the link for the Discord invitation for our group is already added in the description box. So join our Discord group to get the PDFs or files for everything, every video that we upload. Thank you. Let's start with the MCQs first. Sorry, 1 minute, please. Okay, yeah, let's start. Sorry. So for the first question, it seems that the angular speed of the arc is about its axis. We need to find out the angular speed about its axis. This is how, in general case, arcs look like. So this is a complete circle, right? And I'm considering that this is how the axis is like over the like this is the equator over here, and for this equator, obviously, Earth will create one circular pathway. And for one circular pathway, that means the angle would be 2 pi, omega is 2 pi. And obviously, from the equations, like all of the answers you read, I can understand I have to use the angular momentum, right? Or angular speed. So for this case, I can understand omega is 2 pi. This is 2 pi. And about its axis means that time would be what? Basically, we have to convert the total time, like 365 into 24 days into 3600 seconds, right? So that will give you the total time taken over here. So for that total time, oh wait, sorry, not 365. Over the axis means over 1 day. For 1 day, we have 24 hours only. But they're not talking about entire rotation, they're talking about just revolution. For one revolution, about its axis takes 1 day. So about its axis, this was the indication of the time over here. So the time indicates this is day, 1 day, that's basically 24 hours. And then again, this can be broken down further into it's 7.3. Okay, yeah, then that is the case, but we have to write down the work. Okay, it's going to be 3600 seconds. Now we can write omega is 2 pi divided by 24 multiplied with 3600. And as I think Zubair said that answer is supposed to be A, then in that case, answer is 7.3 10 to the power of negative 5 rads per second. Okay, that is a final answer. We are done with question 1. Then for question 2 over here, it says that a particle is moving with a circular path, complete 7.5 revolutions in 9 seconds, and we need to find out the angular velocity. Similar concept.
One revolution is 2 pi, 7.5 revolutions is 2 pi multiplied with 7.5. And this will be entirely divided with the time 9 seconds. How much is that? If I try to calculate the answer for this question, also, another thing, as this angular velocity, in most of the angular velocity questions, we already, I mean, from this question or part also, I can understand angles are measured in radian. So we have to shift our calculator's mode into radian before we carry on with the working. That's 2 pi divided by. How much is the answer? Is anyone still calculating it? B. In that case, 5.2 is your answer. Ifaza, are you still there in class? Yeah, I'm considering that maybe she's having some problem. Let's move on to the next part. So far, we have only done two MCQs. I hope that is clear for all of you. Let's move on to this. It says that the diagram shows a coin on a horizontal surface which is rotating at a constant angular speed, and they have also provided you the like symbol for it, omega, which arrow correctly describes the direction of the frictional force on the coin. As we can understand that only frictional force over here is going to be creating that specific centripetal force, right? A does not represent any corresponding force, a significant force over here to make this particle move on the circular pathway. Yes, D is the correct answer. C is also not a significant force. Okay. D is a reaction force, so that is not again a significant force. Only force that was like acting towards the center of the circle, that was D. So in that case, D is the centripetal force or also the frictional force. Because D was the only force that was acting towards the center of the circle, and because of this D, object will experience a centripetal force, which makes this object move onto the surface of the circular pathway. We're done with question 3 as well. I hope there are no questions from 1, 2, 3. And 1, 2, 3 are actually taken from these question papers from 14, 15, and 18. Okay. Another thing, for all of the worksheets that we're to do, they're all taken out from actual question papers. Gopi, you are a little bit late, so we could kind of completed the first 3 questions.
Okay, ma'am. I'll just watch the recording.
Okay. So I think there's another question. 1 minute. Why isn't friction acting in like the opposite direction of the direction it's turning, like clockwise? In 1 minute. Over here, this shows that exactly how a coin on a horizontal surface, which is rotating at a constant speed. Okay. This is entirely rotating on a constant speed onto a horizontal surface. Over here, this is how the entire thing looks like. This is the pathway maybe, and over here you have a coin. Okay, this diagram represents the coin, does not represent the pathway. Okay, so if that is the coin and it is rotating over here on this circular pathway, so obviously there's supposed to be a centripetal force acting towards the center. The diagram was a little bit confusing. It kind of looks like that maybe this is entirely the pathway, but over here, this one is the coin, as you can see from the very center. Okay, this is the coin, and this coin was acting in this circular, like centripetal direction over here. And centripetal force always acts towards the center. That's why D was your corresponding, what was this? Centripetal force in that case. I hope question 3 is clear for you, Zubair, right? Okay. Then we'll move on. From this part, Gopi, I think you'll be able to understand. So there's some printing mistake, no problem. It says that a toy aeroplane makes 14 full revolutions in 6 seconds. So obviously I can understand this is what 2 pi multiplied with 14. In that case, angular momentum will be, or sorry, angular velocity will be 2 pi into 14 divided by 6, and which is going to be what? 2 into 14 divided by 6 turns out to be, no need to calculate actually. I mean, I can clearly understand your option B is your correct answer, right? 14 into 2 pi divided by 6. That is your correct answer. No other workings are required for it. Let's move on to the next one again. The drum of a washing machine rotates at a rate of 1 to 100 rotations per minute. And we have to find its angular velocity. Again, same concept. That's just going to be 1200 multiplied with 2 pi. 1 minute means we have 60 seconds. So divided by 60 seconds. Right. So just 1200 divided by 60. That is 40 pi. So if you multiply that with 40, it turns out to be 125.66. 125.66, which is approximately 126 rads per second. Okay, this is your question 5. Gopi, since you joined late, is there any problem for this next questions?
No, ma'am.
Okay,
Ma'am, could you do that circle question alone
yes.
again?
Okay. Over here, let's not understand something like anything from this diagram. This diagram is a little bit confusing. Try to understand the entire procedure over here. This pink circle is indicating the overall point, and the black oval line or border line indicates that this is your surface over here. And this pink circle was supposed to travel, like rotate on this horizontal surface. If it is rotating, right, that means obviously there's some centripetal forces acting on the circle. And if you remember, this is exactly the not theoretical classes. This is the horizontal centripetal forces. And for horizontal centripetal forces, what happens? Only friction is responsible to create the centripetal force, right? Around a bend, right? During a bend over here, like for example, when you're moving onto that hilly tracks, there are sharp bends and there are small bends, right? According to your equation, FC m v square over r, if you remember. Yeah, exactly that concept. For a very sharp bend, only friction is responsible for your centripetal force. So over here, these four arrows does not indicate four different forces acting on the particle. These four arrows indicate that in which direction friction should act. In all of the cases, as they're only talking about only friction is present, I'm also assuming that there are also no other forces other than friction present over here. So if only friction is present, that means friction automatically turn out to be the resultant force. And if friction itself is the total resultant force, which indicates that obviously now there is some if that is a resultant force, and because of that resultant force, the coin is moving on a circular pathway, so that resultant force must be the centripetal force. And then again, if it has to be the centripetal force, it also needs to act towards the center, right? So basically, this is how all the parts over here, the question for this is friction is only force, which makes this the resultant force. And I know you guys understood, but I'm just writing all these things. Resultant force is equals to friction, and this time this is also resultant force is equals to your centripetal force. And now if like I can indirectly write this, that centripetal force turns out to be your friction, right? So if friction is a centripetal force, that means it must act towards the center. And out of all the possible directions, option B was only acting towards the center. That is the basic idea for this question. Is there any question till now? Okay, 1 minute. Okay, let's move on to the next question then. Okay, next two are already solved. This is your theoretical question. And then again, we're going to solve all the theoretical questions we can within today. Okay. I don't think it will take much time. Now, over here it says that the gravitone is a theme park ride consisting of a circular chamber which rotates about a central vertical axis. And external view of the gravitron is this one, and this is the internal view of a graviton. Passengers lie back on pads which line the interior of the chamber. And as you can see, the chamber is what kind of inclined, right? And this is the interior of the chamber. They're going to be considering that this is where the beds for the graviton passengers would actually be. So passengers would actually have to lie onto the pad, and then it will rotate on a circular pathway. So it says that these are all inclined at 62 degree to the horizontal. The beds are not entirely vertical, as obviously we can understand this entire thing is inclined, right? So beds over here onto the inclined surface will also be 62-degree inclined from the horizontal plane. And it says that each pad is mounted onto a small track of the graviton wall. As the graviton rotates faster and faster, a speed is reached where the pad rises up to its maximum, rises up its track, so the passenger lose contact with the floor of the chamber. So basically, what happens at the very start, the passengers were connected to the floor, but as the graviton continued to rotate faster, as you can see over here, this was the floor, and none of their feet are connected to the floor, right? Their seats will be lifted up. And then again, it says that the diagram is a free body force diagram of a passenger as the pad rises up the track. R is the normal reaction force acting on the passenger, and mg is the weight. R is normal reaction force, and mg is the weight. You can assume that no other forces are acting on the passenger. This is actually a small mistake. When I was making this entire file, I couldn't actually add one image. So just 1 minute, I have that image already present. Just 1 minute. Send that image to your groups and then use it to copy it over here. This is the image is. Let's just keep the image over here, okay? Because the internal and external view of the graviton is not that much important. Let's just use this space for this because I do not have any space over here. Okay. Now, in this case, it has already stated that R is the reaction force and your weight is mg. As I already know that obviously from our AS classes, that weight always acts vertically downward and reaction force acts perpendicular to the surface. As your plane was inclined at an angle of 62 degree, so maybe this is where your plane was. And if your plane was angled at a 62-degree inclination, that means that's why it was also creating this 28 degree. That means if I have to find out the vertical plane, this is the vertical plane according to that inclined plane, and this is the horizontal plane according to the inclined plane, right? I need to distribute the forces because I know eventually I would have to for the next parts of the question. Another thing over here to understand that how it is actually creating what is this 60 so 28 degrees over here. That is because if you add 28 with 62, it turns out to complete that entire 190 degree. As you know that this angle over here was 62 degree, right? Because this is the horizontal plane. This was 62 degree. That means this over here is also 62 degree, right? And which means that um, this angle was also 62 degree. Right? This is how the entire distribution was. Right? This angle was 62 degree, 1 minute, 62 plus 20. Yeah, this other angle was also 62 degree. So now I'll just keep out these angles over here, and it says that show that the M is 80 kg and the reaction force is about 1700 Newton. Okay, we need to show this forces over here. Wait 1 minute. Let's just distribute the forces and then we'll continue to find that if we can find anything or not. Okay, as weight is vertically downward, right? And we're trying to find out the weight and also the reaction force. So obviously reaction force is equivalent to the vertical component of weight, which is going to be mg cos theta. And mg sine theta is also equivalent to nothing over here. It is also stated that when m is 80, like they are giving you the idea that m is equals to 80, and and you need to use that to find out the total value for reaction force. It is approximately supposed to be 1700. Is there anyone still having any problem with the distribution of the forces on this diagram? Or should I distribute the forces much more properly? Is there any questions still now?
Ma'am, I didn't get it, ma'am.
Okay. I still want to make things a little bit clear, so just wait 1 minute. This is the horizontal
Okay.
plane. So that is just easier for you guys when you're going to revise this. This is the pad, right? And this is going to be the vertical downward component of weight, which is going to be mg cos 62 degree. And this is your reaction force. And over here, if I have to distribute, like if I am distributing the forces, so let's just distribute all the forces. So which is going to be mg sine 62, right? mg sine 62 degree. Okay. Now this is it. All the forces are distributed. And now I can understand that total reaction force is equivalent to mg cos 62 degree. And another thing I can understand, the object was at equilibrium, right? Object means the passenger or the customer, whoever was on top of that seat, they were stationary, right? I mean, yeah, there was a relative movement with the with the relation with graviton. Graviton was moving, person was also moving, but at the end of the day, person itself does not have any motion, right? So in the vertical plane, if you just focus on the vertical plane in this section, the person was at equilibrium, so obviously the vertical forces are zero. So I can use that concept for resolving vertical forces. Resolving vertically, reaction force is equals to zero. And if reaction force is equals to zero, on top you have what? Only R, and then again minus mg cos 62 degree, that is equivalent to 0, which turns out to be reaction force, is just mg cos 62, which is 80 multiplied with 80 is in kg, right? Yeah, okay. Then 9.81 and then cos 62 degrees. Obviously, convert your and like calculators from radian to degree back again. Multiplied with 89.81 multiplied with cos 62 degrees. 1 minute. That written 62 degrees with the weight the person was on this plane. The reaction force was acting. I think the force distribution was not correctly drawn over here because they were saying that the reaction force was supposed to be almost 1700, but I am getting 80 multiplied with 9.81 and cos 62 degrees. Yeah, I'm getting approximately 400. So let's just do another distribution. 1 minute. Let's just consider this that over here they were indicating this, yeah, like approximately 400, right? It's 360. That is not the correct answer then because they have clearly stated that your reaction force was supposed to be 1700. Then let's just distribute the forces in this plane. As according to your diagram, they were only giving you angles with the reaction force and they are considering the weight as the entirely acting vertically downward, right? So in that sense, Let's just distribute the forces in the format they have given. In my previous diagram, I was creating different angles, right? But now let's just, as in my orientation, the answer was not giving you the same answer. Let's just distribute the reaction force over here. Reaction force was, now it's going to be R sine 28 degrees. That is equivalent to the total weight. And in this part, again, you have this R cos 28 degrees. And again, if I just want to focus on the vertical forces, same concept. This time it will be R minus, sorry, not just R, it will be R sine 28 degree minus mg equals to 0, which turns out to be 89.81 divided by sine 28 degree. If we do this, I think then we'll get the final answer. 89.81 with sine 62, sorry, 28 degrees. Yeah, then you are getting 1671.66747. That is almost equivalent to 1700, right? So 1671 Newton. So 72. Yes, 1 minute, 1672 Newton. So that is your final answer. I'll explain this again. In the previous diagram, I was indicating the planes differently, right? In your diagram, as you can see, they have given you 28 degree, which represents that only reaction force was not acting according to any of the plane. Reaction force was maybe in between any two planes, right? But I was actually considering in this diagram that the reaction force is acting perpendicular to the plane. In that sense, your if this is 60 degrees, right? If this is 62 degrees, in that case, weight always acts vertically downward. And if this is where your particle is, in that sense, this is going to create vertical weight. And then again, we're going to create vertical component according to the plane and horizontal component according to the plane. Right, that's what I was creating. As you can see in my diagram, I have to create separate angles, right? And I was not using the angle 28 degree. Over here, they have specifically used the 20, like stated the 28 degree on this free body force diagram because that has a use in A part 1 calculation. Right, that's why we're not going to use this distribution, which is going to be mg, which is also mg cos 62 degree, that is equivalent to reaction force. We're not going to use the previous diagram that I drew because in my diagram, I was introducing different angles, which is not given in the free body force diagram. So we should use only the forces given in the free body force diagram and only distribute the forces according to the angle that are drawn on this free body force diagram, not in my process. Do not add anything extra from your knowledge onto this free body force diagram. Is this clear? Hmm? Then I will erase all these things. And this is your answer for part A1. For Ifaza and Gopi, is there any problem?
No, ma'am.
Ifaza, do you have any question?
No, ma'am. It's the connection issue, I guess. Like, lately delivered.
Understand, no problem. Let's start with the working now. Calculate the centripetal acceleration of the passenger. Now we have the force, right? As you can see, only the reaction force was also acting towards the center of the circle. So basically, reaction force itself becomes your centripetal force this time. So not entirely the reaction force. The horizontal component of the reaction force is your centripetal force, and using this horizontal, what is this horizontal reaction force, I can calculate the angular acceleration easily or centripetal acceleration easily. Right? I already have the mass available, so it's easy for me to calculate the centripetal acceleration. So with that centripetal acceleration, I can use, is there anything else we can use? 1 minute. No, I cannot use anything. Let's just use the basic format, which is what? The equation was maybe need to find out the centripetal, calculate the centripetal acceleration. Yeah, we just need to use Fc equals to MAC. That case, AC turns out to be Fc over M. Fc was what? Over here, only this is acting towards the center of the circle. That is R cos 28. Now, how is RF? 1 minute. How is RF only reaction force? Weight is also acting, right? But weight is not acting towards the center of the circle, right? I mean, over here, entire reaction force is also not the resultant force. Over here, only R cos 28 degree is the reaction force, not the centripetal force. If you remember, this is where your graviton was. Right, this is where your graviton was. And now I think it will be easier for you to imagine only which force is acting towards the center of the circle. That is R cos 28 degree, right? This is the only force that is acting towards the center of the circle. Okay. Then let's start with the calculations. It is going to be 17, not exactly 1700. We got 1672, so we'll just use that. 1672 multiplied with cos, yeah, cos 28 degree, and then again it will be divided with the 80 kg mass. And if you calculate this, you're going to get the value for acceleration. So how much is that? 1672 cos 28 degree. What is the value for your gravity centripetal acceleration? And again, for centripetal forces, centripetal acceleration, always try to write that small c as a subscript for force, F, and acceleration. 8.5. Yeah, I mean, I'm getting 8.4536, a very big value. But all the data given in the question was, according to the question, it was what? Two significant figures, right? 62, 80, and then 1700. All the data given in the question was the two significant figures. I think we can accept like 19, a better version, right? 19 would be a better answer. 19 meters per second. Let's just continue to write 8.5 meters per second square, and then I'll write 19 meters per second square because I'll use 8.5 meters per second square for the next questions, but my final answer is 19 because the data provided in the question was in two significant figures. Now let's move on to the next part.
Ma'am,
It is
the
yes,
cos 28 represents what, ma'am? Here.
cos 28. Cos 28 is a component. As you can see, reaction force was acting in between the planes, right? So vertical plane is arc sine 28 and horizontal plane was arc cos 28. And it is the horizontal plane which was acting towards the center of the circle.
My God, totally forgot to put it.
No problem. Let's
I would have
move
just
on.
used 1672 and done the question.
1672. Wait, 1 minute. I do not understand. Can you repeat?
No, look, like I just told I would have done that mistake. Like I would not have used cos
Oh,
20.
cos 28, right. Now, always try to understand, like, draw a diagram over here. I mean, I think this is again the most toughest question for centripetal force. From the next questions, you will see that no questions are as tricky like this one.
Mm.
Okay, so over here, we now going to find out the speed of the passenger at the moment when the pad rises to, like, starts to rise up the track. The distance from the passenger's center of mass to the center of graviton is this much. They have given you the distance. Okay. 1 minute. I think this distance will act as a radius over here, right? You can understand that previously, maybe this is how the floor of the graviton is, but as a graviton starts to move at a faster speed, the seeds get risen up, right? The seed starts to rise up. That means if this is the original place, 1 minute, if this is the original place, after few minutes, it will move up in this position. Okay, this is the levels over here or levels over here, with up to which the graviton will move up to a higher level. Okay, so this is the start point. I'm not sure if you guys can understand this properly. This is the baseline, and after some time, it will move up to this point, right? That means what? Over here, they're actually traveling a distance of 5 meters, right? Another thing, if they are giving you the, so not 5 meters, they're saying the center of mass of the passenger to the graviton is 5 meters, which means this is the center of the mass. I'll just draw it as a vertical line. This is the center, like this entire vertical line indicates that this along this line, this is the center of the graviton, and from the center of the graviton to the center of the mass or the passenger, I'm considering that now the passenger is over here. If the passenger is over here, this distance is 5 meters. Is there any questions till now? This is also kind of a radius, right? From the center to the circumference, that is a radius. So we have the value for r. Okay, so now we have the value for r, we have the value for acceleration. We need to find out the velocity. So I can easily calculate the find out velocity. Another thing, which velocity I'm trying to find out? Can anyone tell me? Am I trying to find out tangential velocity or angular velocity? What they are trying to like, what I do have to find out over here? The tangential or angular? Which one? Yes, tangential because they were talking about speed. Right, speed means the magnitude only. Magnitude or velocity. So basically, this one is talking about tangential velocity, right? Always in the question paper, they will consider the tangential velocity as linear velocity or just speed. And that is the hint that you have to take to understand. No, we do need the radius for angular velocity also, because basically over here we are using that acceleration in r omega square or acceleration in v square over r. We have to use these equations because in the previous part we used acceleration, mass. So we have to find out the velocities, whatever the velocities in terms of the acceleration. So radius plays a role in both the cases for angular and for tangential. And we cannot use that value theta over time because we do not find, I mean, yeah, okay, for one complete rotation it is 2 pi, but I do not know the time. Right, to calculate the angular velocity from that theta over time, I would need the value for time, but I do not have the value for time yet. So I'm not able to calculate angular velocity with omega t. So yes, we do need radius. So we do need radius for both angular momentum, so angular velocity and linear velocity. I hope that's clear, Zubair. Then over here, I'll just make B the subject, so which is going to be in the next part now. I mean, obviously, I did wrote my answer as 19 for acceleration, but in the next part, as I'm going to carry out the value for acceleration to the next part, I will use that 18.5, not 19. Okay, so it is going to be 18.5 multiplied with 5 divided by 80 and root. How much is the speed or tangential velocity? No, AC is acceleration, centripetal acceleration. Oh, wait, sorry. We're not supposed to multiply mass with this. Sorry. Right, it's just b square over r. Right. Sorry, made a mistake. So only this thing under a root. And then the answer would be a little bit different. What is the answer?
9.62.
9.6. Yeah, I'll just write 9.6. Okay, now again for this in the next part, for part B, it says that the graviton is limited to a maximum rate of rotations of 24 rotations per minute. So 24 revolutions per minute. So that's basically 24 with 2 pi, and per minute means 60 seconds. And now they wanted to find out the linear speed of the passengers at this speed, sorry, at this rate. Then they also like asking you to find out the linear speed. 1 minute. Am I making any mistake? 1 minute. Now we are talking about the linear speed again. This time we have to use that 2 pi like arc length over the time. That is the again another equation we have to use for linear speed. So which is again v arc length over time. For arc length we have 24 2 pi. R is already known to us, right? R is still 5. Sorry, arc length is no, I think over here we cannot use the arc length because we do not exactly know that in what reference they are trying to find out the linear speed. So we cannot use the radius as 5 over here anymore. Let's just use, no, we can use the radius as 5. Yeah, we can use the radius as 5 over here. No problem with that. Sorry. 5 divided by time is 60 seconds. How much is this? Which part, Gopi?
Ma'am, how are we able to use 5? Here, they're just asking for the linear speed, right?
Yeah, linear speed for still the graviton. Right, inside the graviton, the radius would always be same because the customer, like the passengers, are always on the pad, seated on the pad. Right, so doesn't matter whatever, like from whatever angle they're trying to find out. Uh, this is the maximum speed over here. The radius will always be same. Doesn't matter from whatever angle you are trying to find out. Right, from the base or from the top, the final answer would be same. Now I can understand that in this part, basically I was calculating the speed from the base, bottom, right? At the bottom, the entire graviton has a smaller speed, and when it rises up, whatever distance, its speed increases more, and maybe it increases to this 12.56, which I can consider as 13 meters per second also. Is this clear? Any questions till now?
No, ma'am, got it.
That's why it has two different velocities, or two different initial velocities, because over here the speed of the graviton was not constant. At the very start, the speed was smaller when the pads were still connected to the floor, but as the graviton rotates for a longer time, its speed increases and moves to a vertical distance or inclined distance. And after that, the speed again changes, but doesn't matter. At whatever point you are, you're from the center to the center of the passenger, radius is always 5 in that case. Then we'll move on to the next one. It says that an advertisement for this ride states that children feels more comfortable on the ride than adults. And we need to suggest why children feel more comfortable on this ride. Okay. Let's just use that very first diagram you drew for the distribution of the forces. Since I already know over here only two forces were acting, which is reaction force and that weight of the person or of the passenger. So weight acts vertically downward, and your reaction force acts at an angle of 28 degrees inclined from the horizontal plane. So obviously it will be distributed in the vertical plane and in the horizontal plane. Right? This is 28 degrees. This is R. This is going to be R cos 28 degrees. This is R sine 28 degrees and mg. Right. Even though reaction force and weight are not same or same type of force, but they are related, right? I mean, how do you exactly get the value for R? By using this R equals to mg divided by sine 28 degrees. Right. From this part, I can understand that reaction force is directly proportional to weight. If a person have a higher force, they will have a higher reaction force, right? And if a person does not have higher force, they will have a smaller reaction force. Is there any question till now? Wait 1 minute. Okay. Now, as I was saying, let's just draw another circle. Over here, only your reaction force, R cos 28 degree was acting towards the center of this circle, or which was the resultant force, right? Now, in this case, if I can understand that if a person has a larger force, right? If a person has a larger weight, that means a larger reaction force acts on the person, a larger mass means a larger force, and eventually a larger force means that the basically what happens when you are projected to a very high amount of force, you do not feel comfortable as well, right? Over here, for this case, in order for the like passengers to be seated onto the pads, they would need to be like more pushed backward onto the pads to be seated onto the pads. But for a child, if you compare, they have a smaller mass. If they have a smaller mass, in that case, they will have a smaller reaction force. If they have a small reaction force, then they will be pushed more, like less harder back into the seat. For an adult, they will have a larger reaction force. For the larger reaction force, they will be pushed more harder into the seat, right? In order to keep them, remain them on the seat. But if you compare that for a child, they have a smaller mass, they have a smaller reaction force. For smaller reaction force, they will be like placed onto that seat or pad with the less like backward forces. So on children, less force acts, which makes this entire ride more comfortable for children, and for adults, a large number of force acts in the backward direction, for which it's quite uncomfortable for adults because they are pushed very hardly to the seat in order to remain them or keep them onto that seat while the graviton is rotating. Is there any problem till now? And exactly what is this force? This is the opposite of this force. Like reaction force is acting in the upward direction, right? There has to be another force in response to the reaction force. And because of this reaction force inverse, the persons will be pushed very hardly or less hardly onto the seat. Depending on their masses, this R prime force will change. So the larger mass means larger reaction force. So they will be pushed very hardly back into the seat in order to keep them onto the seat while the graviton is rotating. And if we're talking about a child who has a smaller mass, the smaller mass means smaller reaction force. So they will be pushed less hardly onto the seat. Is there any problem till now? This is just the explanation and obviously write down the answer. For Gopi and Ifaza, is there any question from your side? Okay, then we will continue. Okay, as I was saying, I can just write this that children have a smaller mass, smaller force will act onto the rider, so they will be pushed less hardly onto the seat. Onto the seat. Okay, this is the final answer then. And with this, our first theoretical question is done. Okay, I'll just zoom out so you guys can see this entire question. Again, I'm saying that this is actually one of the toughest questions from this circular motion. Now, the next questions are not that much tricky. They're very easy. Okay, I hope there is no problem from this first question. I think this was from what? 1 minute. 2014. Okay, I know these are very old questions, but as I've already stated from our first trial class, that all our worksheets will be from 2013, 14 to 2019, and the recent question paper will do that entirely in year-wise classes. So in that case, in our worksheets, we are basically solving the very old question papers, and in the year-wise classes, we also solve that like recent question papers. So basically, after this entire course, we'll be able to solve, like we have completely solved all the question papers from 2013 to um, the latest one, which is available. I'm not sure if I will be able to get the May 2024 papers, but up to Jan 2024, we'll still have those papers available. Okay, now let's start with 14. When an object moves in a circular path at constant speed, a resultant force is required. State why a resultant force is required and the direction of this force. I know that answer. I mean, obviously, we all know that answer, but because in order to move the object, like make it move in a circular pathway, it has to provide a change in velocity, right? Changing with velocity always creates an acceleration. And if an object has an acceleration, there must be a resultant force for which it will move towards the like onto the circular pathway. And then again, that resultant force itself is your what? Centripetal force. And if that is the centripetal force, in that case, it should always act towards the center of the circle. There are few like hidden things that actually we have to understand from this question. For example, it was saying that circular pathway, sorry, 1 minute, circular path at constant speed. What does this indicate? Constant speed means that they have the same magnitude, right? And circular path means that there is a change in direction continuously for the entire circular pathway, for the entire journey over here. So we are going to first consider this. If you're talking about velocity, it has the same magnitude but different but the direction changes continuously, which indicates that basically it has a changing velocity. If it has a changing velocity, in that case, obviously the object is accelerating. If it is accelerating, obviously it has a resultant force which is basically now your centripetal force. And if there is a resultant force which turns out to be also the centripetal force, this will be the force that is acting towards the center of the circle. Is there any question till now? I mean, for the explanation over here. Center of circle. Is there any question till now? If there is no question, this is like a mini flow chart I have drawn for this particular question. Try to write the answer using this help from the flow chart. And obviously, you guys have to submit the like answer in our group. 1 minute. Hmm. Start writing the answer and send me your working in our WhatsApp group. I'm coming back within a minute. So if there is any problem you guys face, let me know using the text option. Okay. In the meanwhile, please try to write the answer for question 14A. Okay, I think some of you already are done writing the answer. As the object is constantly moving, it's changing its velocity, therefore it is accelerating, and to keep it in its circular orbit, the resultant force has to act towards the center. Why? That is a perfect answer. I still suggest, write all these type of classworks onto a copy. So from the next class, Zubars, attend the classes with a copy so that you can write down. Okay. Not for the theoretical question classes, for the worksheet classes we're going to solve from the next class. Always try to be present with a copy. Now, I'll just write down the answer over here on screen. Okay, I'm just going to copy your exact answer, which is that the velocity of the object is changing, creating acceleration, which required a resultant force, and it should act towards the center of the circle. That is the case. Not exactly creating, causing acceleration is a better word. Which require a resultant force, and it should act towards the center. This is it for your first part. Now for this second part, it says that when an airplane is flying in an upward force, so there is an upward force called lift, which acts at right angles to the wings. So it is not acting at right angles to the horizontal plane. It is acting at right angles to the wings. And when the airplane is flying in a straight line, the lift force is equal to the weight of the aeroplane. Okay. When the aeroplane is flying in a straight line, the lift force is equal to the weight. And on the diagram over here, it says that this is how it will move onto a horizontal circle as it moves at a constant speed. Okay, then again, this is a very repetitive pattern that you see in all the circular motion question. Horizontal circle at constant speed, which again indicates the same thing. It was moving with constant velocities, magnitude, but direction was changing. Right, magnitude was same, but direction was changing. And we'll explain in terms of forces why the aeroplane is able to fly onto a circular pathway. Okay. Before we move on to the overall distributions, like overall concept, let's find out the distribution. So in this case, if I want to distribute all the forces acting on this plane, this is a vertical plane, and then again we have to draw the horizontal plane. Right. As I can see that horizontal, your wings was inclined theta degree from the horizontal plane. And if that is inclined theta degree, this angle would also be inclined at theta degree. Right? The angle between the lift and the vertical component is also going to be same of theta degree. Whatever that angle is going to be exactly theta degree. Is there any person who does not understand that exactly how lift got the same angle as the angle of wings from the horizontal plane? It was already stated in the very first that lift acts perpendicular to the wings, right? So if at the very in entire straight line, this is your wings, right, and this is your lift force, and they were 90 degrees to each other. If this entire thing somewhat gets rotated, so let me just draw a proper diagram. 1 minute. This is your representation for wings, and this is a representation for your lift. Okay, in the straight line, they were entirely perpendicular to each other. Even on the horizontal surfaces, they are always perpendicular to each other. But whenever we want to shift this a little bit, this is how it will look like. It would still be 90 degrees with each other, right? This is how it entire thing gets shifted. Now you can understand easily that if This one gets inclined 30 degree. Then also this particular case over here, let me just draw this down over here. Then you can also understand this will also have the same theta degree of inclination. Right, this was the uh, wings position in the horizontal straight line. This is again the wings position when it was moving in a circular pathway. So it got inclined theta degree. If that is the lift for the like horizontal straight line, then again if the entire plane is somewhat lifted inclined, lift will also be inclined of the same angle. Is there any question till now?
Ma'am, can you actually explain again?
Yes, sure, no problem. Over here, I think you missed a little part over here. In this statement over here, it was saying that the lift of this plane were always acting 90 degrees to the wings. Okay. So I know that this is the original position. Okay, this is what the wings is, horizontal and vertical. In the vertical plane, your lift force was acting. Now this plane is now moving on a circular pathway. To be move on a circular pathway, it somewhat got inclined theta degree. So if your plane was inclined theta degree. That means your wings was creating theta degree with the horizontal. So in that case, what angle your lift would create? So in order to find that, I'm explaining this diagram. If always your wings and lift are 90 degrees to each other, and in order to move on a circular pathway, your wings got lifted theta degrees. So obviously your lift will also get lifted by or shift by theta degrees from the vertical plane. Is this clear? Anyone still have any question from this part? Zubair, Ifaza, any problem? If there is no question, then we'll try to distribute the courses over here. So we have lift. I mean, I know this is theta degree, this is also theta degree. I already understood that from this diagram. So this is going to be lift. Sorry, I'll just write L cos theta. It's just easier than theta. This is L cos theta. On the downward direction, you have weight. And acting towards the center of the circle, you have this L sine theta degree. And it says that explain in terms of forces why the aeroplane is able to fly on a circular pathway. Similar answer to your part A over here. It says that the horizontal component will now, like basically the horizontal component is L sine theta, right? L sine theta is like over here is going to act towards the center of the circle, providing the equivalent, like enough amount of centripetal force for this plane to move on a circular pathway. That is your answer. Like in terms of forces, we have explained that why this plane is able to move on a circular pathway because the horizontal component of lift is acting as your equivalent or enough amount of centripetal force. So your answer over here is going to be, wait 1 minute, of lift, which was actually n sine theta degree, acts towards the center of the circle, providing enough centripetal force. I'll just write FC. Okay, they both mean the same thing, centripetal force. Okay, so we're done with part A1. Let's move on to the next one. It says that the aeroplane now have a mass of this much and is flying onto the horizontal circle with speed this much and theta is this. By considering both the horizontal and vertical motion, calculate the radius. Okay. In order to find out the radius, if you go back to your diagram, if this is the center, in that case, this is your radius. Right, we need to find out that radius. I can find out that radius with if mass is given, right? This is the mass of the aeroplane. Using this, I can find out the lift, and using the lift and lift cos So lift sine 25 degree, I can easily calculate the value for your radius over here. So let's start the working with our calculations for weight in this case. Basically, we'll first focus on the vertical component to find out that lift, because L cos theta is equivalent to mg, right? So we'll have to go, focus on the vertical component first. We'll start resolving from the vertical component. So which is going to be resolving vertically, we have reaction force equals to zero. Sorry, resultant force equals to zero. Why is the resultant force equals to zero? Because object everywhere in the question, it was saying that it was moving a circular situation, circular horizontal, horizontal circle, right? That means over here, every point is it was conducting that the object was moving horizontally, not vertically. That means if there is any unbalanced force, that will only be in the horizontal direction, not in the vertical direction. In the vertical plane, everything is constant, everything is in equilibrium, balanced position. So resultant force turns out to be zero over here. So vertical position, RF is zero. And if for the horizontal part, it is not zero. This is now it's equal to L sine 28 degree, right? Because I already know from the diagram, only L sine 28 degree was acting towards the center. That means that was the equivalent centripetal force, not anything else. Yes, Gopi, if there is any question, please ask.
Ma'am, why can't it be like the wing sine theta, like cos theta? That is also acting in the center only, no?
I'm sorry, yeah, the cos theta is acting in the vertical plane, right? We will use cos theta and weight to find out the limit.
Like for the wings.
Hmm. What the wings? Yeah, I don't understand what wings. Over
No,
here, this wing.
yeah.
No, exactly. Wing is not creating a force, right? The wing is only drawn over here to indicate that exactly what angle your force, lift force will be creating. In order to find out any kind of centripetal forces, we have to redistribute the forces. Forces are lift and weight. The wing doesn't play an important role. Wing was only there to indicate the direction of the lift.
Oh, okay, okay.
Right?
Ma'am, so lift here is considered like a reaction force.
Yeah, lift here is considered as a reaction force, right?
Okay, okay. Got it, ma'am.
But then again, as this is not a ground, so that's why they introduce lift instead of reaction force. Now we are going to write L cos 28 degrees is equals to mg, and it is basically minus mg equals to 0, but then if you just make L the subject of this, it is going to be 2.4 10 power 6, 2.4 10 power 6 multiplied with 9.81 divided by that cos 25 degrees. This is 25, sorry. So how much is this, the value for your lift? Please calculate the value for lift. I am maybe quite late. Oh wait, no, I think I answered that. What is the value that you guys are getting for this lift? 26 million. In 10 to the power 6 then. So 2.6 in 10 to the power 7, right? This is 2.6 into 10 power 7 Newton. Okay. Now for this 2.6 into 10 to the power 7 Newton lift, I can now calculate the value for your radius. But I have already value for your tangential velocity, 85. So basically I'm going to use that FC is now L sine 25 degree. I know this. So using this, I can break down this as mv square over r. No, you're not supposed. No, no, it's not 24. It is 26. The answer is 26. 2.6 or 26. Please recalculate it. It's not 2.6. It's not 2.4, it is 26. Okay, that is equals to L sine 25 degree. So eventually, if we just make R the subject, that will be mass was 2.4 into 10 power 6 multiplied with velocity is, okay, no problem. That is equals to 0. Sorry, 85. Yeah, 85. 10.6 with 85 divided by L was 2.6 into 10 power 6 multiplied with sine 25. If you calculate this, then you'll get the final radius for this circular pathway which was traveled by this aeroplane. Okay, what is the value for the radius then? 185. Wait 1 minute. Yeah,
Ma'am, it
2.4.
should be 85 square.
Oh,
Please.
yeah, right. It will be 85 square. Sorry. Zawahir, can you please recalculate the answer for me? 735. Then it's coming very big. Again, I made a mistake. This was 7. Sorry. The answer should be then 1600, not 1000, okay, because you have 1 0 in the denominator. Basically, you're getting 1578. So obviously, we can round that up to 1600 because all the questions in the data, like all the data in the question were given in 2SF. So I'll write 1578 meter, which will be again rounded up to a 1600 meter. And that is the final answer then. Okay, now, after this, we'll move on. Oh, I think that is it for this question. This was the end for this question. Now let's move on to the next question. It says that the International Space Station is in orbit at a height of 400 kilometers above the Earth's surface, and the ISS completes 15.5 orbits in 24 hours. We need to calculate the angular velocity of the ISS in radians per second. I can easily calculate that. They have like provided everything over here. Uh, that is basically time and what total angle, right? They are saying that it is on a like or it completes 15.5 orbits. So basically, omega is now going to be sorry, theta is now going to be 2 pi multiplied with 15.5. 24 hours means 24 multiplied with 3600 will give you that time in seconds. So in order to find out that omega, it's going to be 2 pi 15.5 divided by 24 3600. Right, that is your answer. If you calculate this, you'll get your final answer, which is approximately 1.13 10 to the power of negative 3 rads per second. Yeah, I can use three significant figures because it was given in 15.5. The like orbits was given in three significant figures. I can use also that in your answer. Now after this, wait 1 minute. Can you guys just wait 1 minute, please? Yeah, okay, sorry. As I was explaining, let's move on to part B. It says the student suggests that ISS is traveling at a constant speed. So, according to Newton's law, there will be no resultant force acting on it. So, we need to criticize these statement or suggestion. Obviously, at constant speed, I mean, ISS was moving on a circular pathway, right? It was maybe stated over here. I mean, it was orbiting the Earth. That means it was moving on a circular pathway. So even if it was moving with a constant speed, it was moving on a circular pathway. So that circular pathway, the direction was continuously changing. So because of that change in direction, the entire velocity was changing, right? As velocity is a vector quantity, so obviously it depends on both magnitude and your direction. Obviously, over here, the student is partially correct, where it says that speed was same, which means the magnitude was constant for that velocity, but direction was continuously changing to be on to orbit around the circular pathway around the Earth. So because of that, there is a change in velocity, which indicates that it must be accelerating. The International Space Station must be accelerating around the orbit, and if there is an acceleration, there must be some centripetal force acting on this International Space Station. Right, so I'll just write down the answer, and then you guys can decide if there is any problem from here. Um, 1 minute. I can refer this as ISS also because it was referred in the question also. I'll just write that the ISS, which indicates it must be accelerating. And then again, if it is accelerating, some centripetal forces. That is your final answer. Please read the final answer and let me know if you have any problem. Oh, wait, sorry, yes. This is the answer for the first question. Yeah, it was 1.13 into 10 to the power minus 3 rats per second. Is there any questions from part A and 1 so far with this question 16? Okay, I hope there are no problems, and let's move on to the next one. I can already understand in order to find out the centripetal force, I have to use omega this time because in part A, I used omega, right? So it's just going to be FC radius is already given. This has to be converted into meters. So it is going to be 64 with another 3 zeros. So basically we'll have 5 zeros in total. So 64 10 to the power of 5 multiplied with mass is 4.91, 4.19 into 10 to the power of 5 with 1.13 into 10 to the power of minus 3 square. Right. So if you calculate all of these things, then you're going to get approximately 34, sorry, 3.4 into 10 to the power of 6 newtons. This is your centripetal force then. Okay, I hope there are no problems from this one. Let's move on to the last question over here. Hmm. In this part, it says that the diagram represents a toy aeroplane at the end of a string, and the toy aeroplane follows a horizontal path of radius r, and the string is at an angle of theta to the vertical plane. We need to like draw the free body force diagram acting on this toy. Obviously, over here, tension will be the force that will act as a reaction force, right? So you have vertically downward as tension, and then again, from this part, tension was acting. So vertically downward is your weight, and in this along the wire, tension was acting. So this is where tension will act. And again, I can understand a component of tension will be the centripetal force over here. If this is the circle they're creating, this is the horizontal force, horizontal component of tension. This is the vertical component of tension. They were creating like tension was creating vertical angle with a vertical plane. So which means this is theta degree. So it is going to be T cos theta and T sine theta. Again, I do not need to write all of these things. Only the pink lines are supposed to be drawn onto this diagram. Okay, but I'm just only like distributing all the forces over here because this will be needed for your calculations for part A2. For part A2 now, it says that the toy aeroplane completes 36 revolutions in 1 minute. So we need to find out the speed. Calculate the speed. Speed means that we are trying to find out the tangential velocity, not the angular, and then again r was given over here. So if this is becomes 0.4 meter because it was in centimeters, we have to convert that into meter. And in that case, v is arc length over time. Arc length was 2 pi r divided by time. So 2 pi 0.4 again multiplied with 36 divided by 60. Time was 60. Right. So if you calculate all of these things, you're supposed to get approximately 1.51 meters per second. Okay. Now after this, we are going to move on to the next part by considering the vertical and horizontal components of tension above of tension show that the angle theta is independent of the mass of the toy. Okay. Let me just read down the question again. Over here, it says that by considering the vertical and horizontal components of the tension, we need to show that theta is independent of the mass of the toy. That means we have to create an equation for tension where mass is not related to it. Okay, that is what it indicates that theta is independent to the mass of the toy. For that, let's just distribute the forces again over here. These were the vertical and horizontal forces, and your tension was somewhere acting around this plane, right? And it was creating theta degree with the vertical plane. So basically, you have T cos theta and this is your t sine theta. And in the downward direction, you have weight, which is basically mg, right? As it was related to mg, so let's just write this over here. I can understand one thing is that if I distribute the forces vertically, resolving vertically, you have what? Resolving vertically is basically t cos theta minus mg, that is equals to 0. So eventually for mg only, you're going to get, for tension only, the value is tension mg divided by cos theta. But this, in this equation, tension is actually related to mass, right? Because we are getting T is equals to mg over cos theta. Even for the value for tension, you have that mass involved. And we are trying to find out that, wait one minute. So that the angle theta is, so sorry, I read the question wrong. We are supposed to make theta the subject of this formula, not tension. Sorry. In that case, I'll just consider writing this as, I'll write this as cos theta divided by tension. Okay. Now this is again, we're not at the final answer, because over here your cos theta is related to mass, right? Because mass is still there in the equation for cos theta. So this is not the final answer. We have to distribute the horizontal forces over here as well. So for the horizontal forces, I can understand that T sine theta was actually your centripetal force also, right? So as your centripetal force was T sine theta, so we're going to start with that resolving horizontally. For that resolving horizontally, now I can write that RF is basically equals to FC, right? So in FC, you have what? Resultant force is T sine theta, and that is equals to what? M R omega square, right? So M R omega square. So let's not write, like, let's not make sine theta cos theta the subject of this equation. 1 minute. Let me do the resolving forces for vertical plane again. I'll explain this once I am done doing the derivation. 0 and 1 minute. You are supposed to have t cos theta equals to mg, right? In that sense, I'll just make t the subject of this. Yeah, then I'll substitute the t on the left equation, and then it will give you the relationship for theta regardless of tension. Okay, that is your first equation. And this is your second equation. And now I'll substitute the first equation into the second equation. So I'll just write substitute 1 into 2. And then you're supposed to get what? Instead of writing t, now I can write mg by cos theta, right? So which is basically mg multiplied with sine theta over cos theta, and that is equivalent to mr omega square. I can clearly understand this masses gets cancelled out, and at the end I'm going to be left out with sine over tan cos is tan theta. So basically you have g tan theta equivalent to r omega square. So yes, this is a final derivation that g tan theta is equivalent to r omega square. So which means now we're going to get tan theta. I can just write this down as tan theta r omega square over g, and final case, I'll just make theta the subject, which is basically tan inverse r omega square over g, right? Is there any problem till now?
Ma'am, actually, could you explain the mg into sine theta by cos theta? That alone again. How do you get that?
Wait, mg, oh, yeah, that is what? In the vertical plane, the object is in equilibrium, right? So resultant force is 0. So you're going to get RF equals to 0, which is basically T cos theta minus mg equals to 0. You just take that mg to the right hand side and then divide it.
The resolving for the horizontal direction.
Oh, for the horizontal direction. I know that this is where your circle was, right? So only this T sine theta was your entire centripetal force. So over here, as your entire plane was moving, so your plane or whatever the toy was moving on a circular pathway. That means resultant force is equal to centripetal force in horizontal direction,
Mm.
right? So, and then again in the horizontal plane, you only have this T sine theta. So basically you have this T sine theta as your entire resultant centripetal force. Let's say T sine theta is equivalent to mr omega square. Is
Yeah.
this clear? Okay.
Okay. Oh, you're just
Um,
substituting T. Okay, okay.
yeah,
Got it.
I'm just substituting that over here. Right? I'll just keep it over here. Okay. Now we're done with this first part. Now, in part B, it says that suggest a value of or theta that can be determined experimentally. I mean, if you go back to the diagram over here, everything is happening in the air medium, right? I cannot obviously hold a meter ruler or any kind of cases over here. And in order to find out theta, what are the values you need? You need the value for radius, right? And then again, you need to find out the value for omega. Omega, again, it's a derived quantity. You have to calculate that using theta over time. Okay, time can be calculated using a stopwatch, but theta, radius, g is again a constant over here. So exactly how would you calculate or measure this type of things, this type of quantities, radius, theta, in air medium? The best option over here is that you can like shot this entire movement of the toy aeroplane into a video camera and then rewind the video every time to find out the time for one complete circle, angle from the video, and then again the radius of the video. Is this clear? Right, so just write that use video camera and rewind the video to take measurements for radius. Let's just break down omega. Omega would be radius and theta. Okay, these are the only things. So radius, omega, and time. Right? These are the only things you have to calculate. Radius, theta, and time. Is there any problem till now? Okay. If there is no problem, then that is the end for your worksheet 2 for centripetal forces. And from Monday classes, we're going to start with your electric fields. Okay. And again, obviously, we are going to solve another big worksheet from centripetal forces that will be given to you guys in form of homework. That will be homework 3 and 4. But before that, we guys have to complete that worksheet 2 and 3 by this week Sunday. Okay. In that case, so no new homeworks from like circular motion. Only try to find out the homework or finish the homeworks for momentum within this week. Okay, then, thank you for joining the class. I'll stop the class over here. Bye bye.